Hey you guys, welcome back. We're going to jump into our next lesson, which is on geometric sequences. So as always, make sure that you go on Google Classroom and print out these blank notes or get some blank paper out so you can follow along. And don't forget to put your name on the top of your paper. So Dansby, and this is Unit H, Lesson 4. Don't forget the date. I think this is probably, my pen's covering my face right now. That's cool. Okay, so the date that I'm doing this today is actually Sunday, but I'm going to put Monday's date. And don't forget to put your period number here in the class field. Okay, so a geometric sequence is kind of similar to an arithmetic sequence. The difference is that in a geometric sequence, we're talking about multiplication. So there's a factor called a common ratio that's going to be what you multiply each term by to get the next term in the sequence. So we can go ahead and define a geometric sequence. That is a sequence where there is a common ratio between any two terms. And in order for it to be considered a geometric sequence, that common ratio has to be the same every time. Just like in arithmetic, you have to add the same number every time in order for it to be considered arithmetic. The same is true for geometric. You have to be multiplying by that same term or that same ratio every time you go between terms. So the common ratio is that numerical value and that's the numerical ratio between any two terms. And I'm going to switch colors here so we can sort of emphasize this. Let's use orange, go Gators. So the variable that we are using for this is R. So remember in arithmetic sequences we were using the letter D, the variable D, to represent the common the common difference among the terms. In the geometric sequence and series, we're going to use R to stand for ratio. So that's going to be a little bit of a difference there. Okay. Okay, so let's do some example problems. The rules or the directions say determine whether the sequence is geometric. If it is, then identify what the common ratio is and give the next three terms. More times than not, you're going in a problem like this, it's probably going to be geometric. Otherwise, you wouldn't really be doing much work. So let's look at the first problem, and I want you to compare the terms. So just like how we did in our arithmetic, we would do this little like upside down caret between each one and find out what's happening between them, what's changing about it. And so it looks like you're multiplying 6 by 2 to get 12, and is the same thing happening between 12 and 24? And the answer is yes. And then 24 to 48, it looks like that's also doubled. So yes, this is geometric. We're going to say yes it is. And then we need to identify the common ratio. So what is R? And R is 2, positive 2, because you're multiplying by positive 2 each time. And then it says to give the next three terms. So you're going to double 48, and then you're going to double that, and then double that. So I'll go ahead and switch colors. So the next term is going to be 48 times 2, which is 96. So 96 is our next term, and then we need two more. So we're going to double 96 to get 192, and then we're going to double that to get 384, and those would be the next three terms in the sequence. Okay. Let's take a look at number 3, because it looks like we have some differences happening with the signs here. Okay, so if you're going from term to term, we need to figure out what we're multiplying -2 by to get positive 10. Well, a negative times another negative will give me a positive. So this number here, this difference, this ratio is going to be a negative number. So we're going to multiply that by negative what? It's going to be negative 5. And then let's find out what the ratio is between 10 and negative 50. And is it negative 5? And the answer is yes, because if you multiply 10 by negative 5, you get minus 50. Now be careful here with what I'm writing, because this kind of looks like x minus 5. That's not what I'm writing at all. I'm just signifying this is multiplication by negative 5, okay? And then let's look again at negative 50 and positive 250. If you multiply negative 50 by negative 5, you are going to get a positive 250. So the answer here is yes, it is a geometric sequence. And the common ratio here, the R value, is going to be negative 5. That's what you're multiplying by, is negative 5. It says to find the next 3 terms. So we're going to take positive 250 and multiply it by negative 5. We're going to get negative 1250. And then we're going to multiply that by negative 5 to get our next term, which is 6250. And then one more time, times negative 5. We get negative 31,250. Okay, so let's take a look at number 5. So in number 5, it looks like we have some sign switching. So we have positive, negative, positive, negative. So our ratio is going to be a negative number again, just like we saw in the last one. But we have something happening here where instead of the numbers getting larger as you go through the sequence, they're actually getting smaller. So this might trip some of you up, because you might be wondering, like, what do I multiply this whole number by, which is 4, to make it into a negative 1? So anytime that it's getting smaller, you're going to have a fraction as your common ratio. And a really easy way to find out what that common ratio is going to be is actually to go from like the end of the sequence and go backwards. And instead of multiplying, you're going to divide, because if you divide, then you're going to get whatever this is multiplied by to get this. Does that make sense? Okay, so if we were to do that, in my calculator, I'm going to start at negative 1 over 16. And I'm doing this in parentheses on my calculator here, because I want to make sure that my signs don't get messed up. And then I'm going to divide that by the term before it, which is 1 over 4. And I'm going to get negative 0.25. Well, negative 0.25 is negative 1/4, okay? So for these two terms, I'm going to say negative 1 over 4. I'm not going to write the x anymore, because I think that's confusing. Okay, so then let's do one more term here, and let's see if negative 1/4 is the same ratio between all the terms. So it's 1 over 4, and we're going to divide that by the term before it, which is negative 1. And I get negative 0.25 again, so I know my ratio for this one is also going to be negative 1/4. I'm working backwards in order to find, I'm dividing backwards to find that common ratio. And then one more time, if I take negative 1 and I divide that by 4, it looks like I'm going to get negative 0.25 again, so we can just put negative 1 over 4 here. And this is geometric because I have the same ratio between all the terms. And my R value here is going to be times negative 1/4. So if you were going the correct direction, which is from left to right, and you're multiplying, every term that you find, you're going to multiply the previous term by negative 1/4 to get the next term. It also says to find the next 3 terms, so let's do that. So we need to take negative 1 over 16 and multiply. Now we're multiplying now, not dividing anymore, because we're going from left to right. Okay, we're finding more terms. Negative 1 over 16 times negative 1 over 4. Whoops, I messed up because I didn't type the right thing in. Let me try that one more time. Negative 1 over 16 times negative 1 over 4. And I get, okay, so it's a decimal, and I'm going to be okay if you guys leave it as a decimal, but there is a trick on here on this graphing calculator where I can just turn it into a fraction. Something else that you can look at too is that as you multiply fractions, you multiply across the top and across the bottom denominator. When you multiply 1 by 1, it's always going to end up being 1, and the denominator is going to be the previous denominator times 4. So another way to look at that is just 16 times 4 is 64. So the next term is positive 1 over 64, and then the next term after that is going to be a negative. It's going to be a 1 over, and then we just need to do 64 times 4 to find out what that denominator is going to give us. So that's 256. And then one more time. So a negative times a negative will produce a positive, so it's just going to be 1 over something. And we need to do 256 times 4 to get that denominator, which is 1024. Okay, I'd like to do one more example from this section here, and I want to do one that is not geometric, just so we can show one of those. And I know that number 4 is not geometric, so let's do that one. 4 times something gives me 8, and that's going to be 2. And then 8 times something gives me 20. So that's not even going to be an easy. That's not going to be a nice clean number. It's going to be like a mixed number, a whole number, and a fraction. But if I divided it, I could find out what that is. It's 2.5, 2.5. Okay, and then one more time, 20 times 3 gives me 60. Okay, so the ratio is changing each time, so this is not geometric. No, ratio is changing. It doesn't say to give a reason, but I'm just giving you one just so you can, have it spelled out for you. Okay, so for your classwork, you're going to have to do number 2, 6, 7, and 8. And if you want, you can pause the video now and do them because we're in this part of the notes, and it'll be good practice for you. So go ahead and you can pause. Okay, so we're going to move forward onto the next part of the notes, which is about the geometric sequence formula. So just like arithmetic sequences and series, there's a formula that we can follow. Or otherwise known as a rule. We can make a rule for any of these geometric series as long as they have that common ratio. So let's fill in what is happening here for the rule. The rule says that you can find any term, the value of any term of the sequence, by taking the first term of that sequence, and then you're going to multiply that by the r value, or the ratio, and that r value is actually going to be raised to the exponent of n minus 1. So kind of similar to what we were doing in previous topics. You need to figure out what n is. Okay, so keep in mind too, I'm going to make an additional note here that a sub n that you see over here is the value of the nth term. And when you see the little n inside of your formula, that means it's the number term that you're working on or looking at. So just to clarify what I'm saying, what I mean is that let's say that n is 7. That would mean that we're looking at the 7th term. Okay, that's position 7 in the sequence. But the value of a sub n is whatever the value is at the 7th position in the sequence. Okay, I just want to clear that up in case anyone was confused. All right, so let's fill in. A1 is the first term. Oops, and I'm going to scroll these notes up because you can't see what I'm writing. Okay, so that's the first term, and then the r value, if I zoom a little bit here, I have to be careful because I might move my camera out of focus too. Okay, so the r value is the common ratio. Okay, so I want to make sure that you can actually see this, so I'm just going to fold my paper in half real quick, so just put it in tight. Okay, so we're going to look at these examples here on the bottom of the page, and the examples say write a rule for each sequence, and then once you've written that rule for the sequence, they want you to find the 6th term in the sequence. Okay, I think that's probably just a little easier to see everything now. Okay, so here's the sequence. It's 1, 5, 25, 125, etc. So in order for us to figure out what we're plugging into this rule here, the first thing we need to figure out is what's the common ratio. So what do you multiply 1 by to get 5? What do you multiply 5 by to get 25? And 25 to get 125? You're going to multiply that by 5 each time. So the r value is 5. The first term of the sequence, they told us that already. The first term I'm pointing to right here is 1, so a sub 1 is 1. And then the only thing that we would otherwise need to do is, like, once we're applying this rule, we would need to know what term we're looking at. But for now, we have enough information to write the rule. So the rule is that to find any term in this particular sequence, so any term in this sequence, you're going to multiply the first term, which is 1, times the common ratio, which is 5, to the power of n minus 1. So that's it. You don't know what n is yet because you don't know what term you're looking for. So this is all that you can do. This is the most that you can plug in. I'm going to use a different color so we can go ahead and find what a sub 6 would be. So let's cross that, divide that up. So a sub 6, or the sixth term, means, so now I'm solving for the value of the sixth term. So I know n is 6, but I need to know what a sub 6 is, or what the sixth term is. So we're going to use our rule, which is 1 times 5 to the power of n minus 1. N is now 6. Okay, so 6 minus 1. And this part right here, this is all a numerical value now. So all you really need to do is just calculate that and you will have your answer. So we need to do our exponents first because that's what happens in PEMDAS. So we need to do 5 to the power of 5. Well, 5 raised to the power of 5 is 3,125, and then we're going to multiply that by 1, which is itself. So the sixth term in this sequence is 3,125. I'm going to box my answer. Okay, let's try, let's see. There's a lot of examples for this section, so I'm going to do 10 with you. It looks like the numbers in this sequence are getting smaller. So it's not going to be like as easy as it is to find when they're getting larger because this is easier to guess. You can figure out what you're multiplying by to get a larger number. It might not be as obvious to go backwards when you're trying to go smaller. So we're going to go from right to left and divide to find out what the common ratio is. So take 16.25 and you're going to divide that by 32.5. That's a half. Do it again, so 32.5 divided by the term before that. Whoops, 32.5 divided by 65. That's a half. 65 divided by 130, excuse me, 130, and that's a half. So our common ratio here is 1/2, and the first term in the sequence is 130. So we have enough information for us to write the rule. The rule that you can use to find any term is a sub n is equal to the first term, or a1, times the common ratio, which is 1/2, and we're going to bring that to the power of n minus 1. And that's the most that you can do unless you know what specific term you're solving for. And in this problem, we do know that. We're solving for the sixth term. That's what the directions told us to do right here. So let's go ahead and use this rule. So a sub 6, or the value of the sixth term, is going to be 130 times 1/2 to the power of 6 minus 1, or the fifth power. So all you really need at this point is a calculator. You need to take the value of 1/2 and raise it to the power of 5, and then multiply that by 130. So the answer here is 4.0625. I'm sure there's a nice fraction representation of that. It's 65/16. I'm honestly fine with the decimal as long as you're doing the rest of this right, then this is really inconsequential to me. Okay, so if I flip my page here, I'm going to move this out of the way. We have a couple more examples to do. I'm actually going to leave them for you as your classwork. So 11, 12, 13, and 14. And once again, if you want to pause the video here, this would be a good stopping point for you so you can take a look back at the rule on the first page right here and the two examples we just did. You're going to follow the same directions, which is that you're going to, 1, write a rule for the sequence, and 2, figure out what the sixth term is, or a sub 6. So go ahead and pause the video and do 11 through 14. Okay, so we're back and we're going to work on 15 through 18. It's a little bit of a different type of problem because in these problems right here, we have some information already about the sequence, whether it be the first term or another term in the sequence, and maybe they gave us the R, maybe they didn't. And then they asked us to find a specific term in the sequence. So let's just dive right in. We're going to go to 15. The first term in the sequence, or a sub 1, they gave this to us, it's 7, and then we know the common ratio is 4, and it says to find the 8th term. So that's easy enough. Just go back to your rule. The rule says that to find any term in a sequence, if you have a sub 1 and R already, all you need to do is do a sub 1 times the R value to the power of n minus 1, which is going to be 8 minus 1, which is 7. So go to your calculator and do 4 to the power of 7, and then you're going to multiply that by 7. And then that tells us that the 8th term in the sequence is 114,688. Pretty large number, but you know, it happens. If you found even the second term in the sequence, it would be 4 to the first power times 7, which is 28. So you're going from 7 to 28. It's only going to get larger from there. Okay. Okay, so I'm going to do 18 with you guys, and then I'm going to leave 16, 17, and the application problem for you to try. Okay, so 18 is actually a really cool problem because they gave you the second term of the sequence, not the first term, and they gave you the 5th term of the sequence, and they want you to find the 4th term. So you don't have a sub 1 and you don't have R. So there's a little bit of kind of like reverse engineering that you're going to have to do with this problem. And so the first thing that I want you to realize is that in a sequence, if you decided that you wanted to start at the second term, you can make that a sub 1. The only difference is now, for the rest of the terms that you're looking at in that sequence, you have to kind of reprogram or retool what number term that is in the sequence, because now you've basically shifted one forward from a sub 1 to making a sub 2 be the first term. So for example, let's say this is the original sequence. We don't know what a sub 1 is. We know a sub 2 is 6. We don't know 3. We don't know 4. And we know that a sub 5 is 0.048, okay? And it goes on and on and on. And right now, this is not enough information for us to find anything. But if we decided to just take from the second term up to the 5th term, okay, then this now becomes a sub 1. So this one, instead of it being a sub 5, is now 1, 2, 3, the 4th term of the sequence. And so this term, this was originally a sub 4, which is what we're trying to solve for, but it's no longer a sub 4 because we're only looking at this little glimpse of the sequence. This term is actually now a sub 3. So just keep that in mind as we go forward. We're going to be looking for a sub 3 when we finally figure out what our rule is. So if we know a sub 1 is 6, and we know the 4th term is 0.048, we can plug that into our formula for geometric sequences, and we can figure out what the R value is. So the 4th term is 0.048, and that's going to be equal to the first term, which we're now calling is 6, okay, times the common ratio, which we don't know what that is yet, to the power of n minus 1. Well, this 0.048 is the 4th term, so n would be 4. So that would be 4 minus 1. Okay. Let's go ahead and actually divide both sides by 6 so we can kind of isolate this value here. And that's going to be 0.048. Whoops, calculator's off. Divided by 6. That's going to give us 0.008 equals r to the 3rd power. 4 minus 1 is 3. So How would we get r now? Well, we'd have to cube root both sides of this equation in order to get r. And so in order to cube root, I have a button for that somewhere in the calculator, but the easier way to do it would just be to take 0.008 and bring that to the power of 1/3, and that's 0.2. So our r value is 0.2, okay? So knowing that information, we can now go ahead and we can make a rule for this sequence to find the third term, which is actually going to be the fourth term from our original sequence. Remember, we shifted everything over and just looked at one little part. So the r is 0.2. That means, and I'll use a different color for this one, this means that to find the third term, we need to take the first term times 0.2, which is r, to the power of 3 minus 1. So take 0.2, raise it to the power of 2, and then multiply that by 6, and you get a sub 3, the third term in the sequence, is 0.24. This value right here is 0.24, and that's going to go ahead and actually be your answer. Okay. I'm actually going to leave 16 and 17 and the application problem for you guys to work on. Okay. This was Monday's lesson. This was on geometric sequences, and I will be available for office hours tomorrow, Tuesday, from 10:30 a.m. to 1:30 p.m. So if you have any questions about anything from this lesson, feel free to drop in and ask me. All right, guys, see you next time.